But this question of the realness of space, the thinginess of space, I don't know if do you know about the Clark-Leibniz correspondence?
You and I have spoken about this.
Is space relational or substantival? Is it a thing or is it just a collection of relations? And fact, to keep in the back of our minds when we're contemplating that question, is that space isn't really empty, or it's not featureless anyway, because it's filled with all these fields, like the electromagnetic field. So you do a great job in your book talking about what a field is, the idea of the fundamentality of fields, which is very bizarre to people, right? Like, they always want to know what the fields are made of. And I gotta say, like, no. The things are made of fields, not the other way around.
Right. Part of the problem with talking about fields and what they are is that fundamentally we don't know. It's always harder to explain something you don't really understand. We understand what fields do with remarkable precision in many cases. We have math that describes what they will do in all sorts of circumstances. We can predict all sorts of wonderful details. But just because you can predict what something does doesn't mean you really understand fundamentally what it is. And an analogy I like to use that I think is reflective of the right way to think about fields is that if you think about the atmosphere, just think about the air of the Earth. It has all sorts of features that you can measure. It has pressure, it has temperature, it has wind meaning how fast it's flowing in a particular location. And these things, pressure, temperature, wind, humidity, these are properties of the air that you can measure anywhere. There's some machine you can use for, measuring wind speed and direction, et cetera, et cetera. But imagine that you didn't know what air was, and all you had was these measuring devices. You could measure this thing which you call pressure, but you don't have the conception that it is literally the pressure of a gas. You just call it P.
Yeah.
And you measure this thing called T, it's temperature, but you don't know that. And something called W, which is wind, but you don't know that. So you have these things you can measure, and you can figure out equations which describe how they work, and you can even predict the weather if you're clever enough to figure out the right equations.
Yeah.
Because the equations stand on their own. They tell you how these things you can measure change over time and how they relate to each other. But if you don't know what air is, or even necessarily that it exists, then you don't know how to think about pressure. You don't know what property of air it's referring to. And since you don't even know what air is, you can't even sort of talk about what property it might be. And this may be our situation with the fields of the universe, where the vast majority of the fields, with one interesting exception that I'll come back to, they seem to be properties of the universe, the way pressure is a property of air. That might be the right way to think about them, but we have no idea which properties, and we have no idea what the substance of the universe is. And the one interesting exception is gravity, which is ironic because in many ways gravity is the one we understand the least from the point of view of quantum physics. But in the case of gravity, the gravitational field is telling you about the property of space, which we call curvature, the degree to which it's warped. So it is possible that the electromagnetic field is telling us some property of space and time that is not obvious, some sort of hidden property that we have yet to learn. In string theory, for example, that's a common situation. Not to say anything pro or con against string theory, but it is an example of a context in which the luminiferous ether does exist. It's a part of space-time. And so it may be that this notion that space and time are a substance that has many properties, and those properties are the fields of nature, that may be a perspective which is at least useful and maybe even somewhat fundamental. But we still have to deal with the fact that space is very strange because you can't measure your motion with respect to it. So if it's like a material, it's not like anything we've ever seen.